Hello, my name is Hellina Hailu Nigatu, and today I'm going to talk about how we could use HCI to inform technological design for low-resource languages. So I'll start with a bit of introduction about myself. I am a third-year PhD student at UC Berkeley in computer science. I received my bachelor's degree in electrical and computer engineering from Addis Ababa Institute of Technology, and I specialized in communications engineering. I got my master's degree in computer science from UC Berkeley, and prior to starting my PhD, I had a research experience in computer architecture and hardware security, and I also did a little bit of data science for healthcare. And when I started my PhD, in my first year, I focused on a project that spanned human-computer interaction, natural language processing, and a bit of image processing. And starting in my second year, I focused more specifically on low-resource language NLP with a bit of ethics and fairness background. So I will start with some definitions that will allow us to think about the concepts that I'll talk about in this presentation. First, let's define what HCI is. A lot of people define HCI in a lot of different ways, but my favorite perhaps is from this book that defines HCI as the intersection between social and behavioral sciences and computer and information technology. So any research that studies how humans interact with computers and technology more generally and uses social and behavioral sciences to do that, that research or that investigation can be considered as HCI. HCI is very broad. It could be VR research, it could be smart fabrics, it could be user interface and user experience design. So it's a very broad multidisciplinary field. Now I will define what low-resource languages are. So some people like to call them low-resource languages. I like to call them low-resourced languages. They are languages that do not have sufficient available data, for example, to train large models. So the current trend in NLP or deep learning more generally is to collect more data, use more compute, and have bigger models with more parameters. I like to use this meme to explain this concept. If you, a machine learning system is you pour data into a big pile of linear algebra and collect the answers on the other side. And if the answers are wrong, you just stir the pile until they start to look right. And the problem with this for low resource languages particularly is that you do not have enough data to do that steering so that you can get the right answers at the end. So there are some alternatives that we see in the NLP world for this. Here's a paper from some folks at Berkeley as well as Google on how we could use human-centered design principles to improve machine translation systems. This is a screenshot of a company called Lisan AI that focused on collecting quality data for Amharic and Tigrinya to English translation and actually built a translation system that performed better than the commercially available Google or Microsoft translation system for these low resource languages. We also see low resource language research or the impact of lack of research in low resource languages per se in terms of content moderation, where, for example, low-performing automatic content moderation systems fail for languages that are not English or languages that are low-resourced and result in direct downstream harm. Not everything is dark. There are also efforts to improve these systems for example, in speech recognition, there's a project by Mozilla called Common Voice where people can contribute voice to crowdsource speech data sets to train models for example, speech recognition or text-to-speech, etc. So currently in NLP, the alternative that we see, especially within the low resource language space, is community-centered research, where, for example, we have Masakane, which is a grassroots NLP community for Africans, and it includes Africans that speak a diverse set of languages that are all set on putting African languages on the NLP map. So this is collaborations across multiple people who speak a lot of African languages coming together to work on projects to improve systems for their languages and their communities. There's also Lanfrica, which is a repository for datasets for African languages. And what's common across these communities is that it is by the community members, and everybody is invested in improving technologies for their languages. That's a screenshot from a project that we did in 2022 from Masakane, where we curated African stop words and built a system that would allow us to scale up as more languages are included in the system. So how do low resource language, NLP, and HCI exactly interact? So low resource languages have minimum data available by definition. So HCI could really help us, for example, in terms of data collection efforts. It could help us think about how we could collect data that respects community values, how we could do data collection in a way that reflects the community members' existing practices, etc. And from the NLP angle, we could supplement this by working on efficient algorithms instead of requiring more data to train larger models. HCI could also help us think about how we could design systems that are modular so that as we add more languages, we could easily scale horizontally or be more inclusive of other languages instead of requiring the languages to adopt to our systems. And perhaps a question that will frame the remainder of this talk is that HCI could also allow us to ask the critical question of why do we need this technology, or do we even need it, or are we just building it because we think it's cool, which is also fine. But if we're thinking about building systems that benefit certain community members, we could use HCI principles to investigate how we should build that technology and what the needs of the community really are. So with that, I'll talk about a project that we worked on with my advisors, Professor John Kenny and Professor Sarah Chasins, on low resource languages and online knowledge repositories. And this is a need finding work that will appear in CHI 2024 in mid-May. So I'll start with a bit of a motivation. I'm sure most of you here are aware of Wikipedia. It's a free encyclopedia available in over 300 languages and has over 191 million articles in total. And the vision statement for Wikipedia is for every single person on the planet to be given free access to the sum of all human knowledge. And not all languages on Wikipedia are represented the same. Low resource languages suffer in terms of quantity, so there are limited number of articles, limited number of new articles per day, and active editor counts for low resource languages as compared to their higher resourced counterparts. There are also quality issues. Existing articles are short, redundant, or simply stubs. It might just be one word, it might be just one long sentence, and it might also be unrelated to the title. Zooming out, we see that for low resource languages, the peak number of sentences per article is 1 for most articles, while for comparison, for Arabic, for example, the most number of sentences in an article is at around 10. There's also relevance issues with existing articles. This is a screenshot of an article about the Big Mac burger on the main page of Amharic Wikipedia, although there's no McDonald's restaurant in Ethiopia at the time of recording this talk. And an article about a famous community in Ethiopia called Dauramba is available in 6 languages, none of which are Ethiopian. So we see that Wikipedia for low resource languages suffer in terms of quantity, quality, and relevance. So we asked the question, what challenges do low resource languages contributors face when interacting with online knowledge repositories? In other words, we wanted to know why there's not enough quality data available in these languages. To answer this research question, we conducted 2 studies. First, we collected forum discussion data from Wikipedia contributors in 3 low resource languages and used inductive thematic analysis to understand what challenges they talk about. And since contribution in these languages is low, we conducted a second study where we observed 14 novice contributors attempt to write articles in one of the 3 languages that they choose, and we again used inductive thematic analysis to analyze the data. So when we started this project, we were expecting that we are going to find out exactly what is wrong with the Wikipedia interface that is preventing people from contributing in these languages. But what we found is that the challenges are not limited to the Wikipedia interface, but are rather the interaction of several different challenges spanning Wikipedia's interface, language support tools, and social political challenges. I'll start with Wikipedia's interface challenges. We observed several challenges, including sometimes interface interactions would be mixed in the local language and English. Here's a screenshot from one of our participants receiving a permission error that their IP address is blocked, and the instructions are in a mix of Tigrinya and English. There were also several discussions on not being able to use non-Latin fonts on the Wikipedia interface. This is a dialogue between the designer and two Wikipedia users on Amharic Wikipedia who are complaining that the fonts are too bold or appear to be bold, and the designer, who acknowledges that they cannot read Amharic, does not understand what the users are trying to tell them when they say that the fonts are bold. There are also issues with Wikipedia not handling different spellings, which lead to duplicate articles. In Amharic Wikipedia, this surfaces because of several characters that have the same sound being used to write the same word in different ways. And in Afan Oromo Wikipedia, this surfaces because of differences across dialects in how to spell the same word, and sometimes due to entirely wrong misspellings that lead to duplicate articles. This results in users not being able to search and find articles, and wastes editors' time removing and finding duplicate articles. Now let's move on to language support tools. We observed several challenges, but in this talk, I'll only highlight one language support tool, which is the machine translation tools that our participant used. Here's a screenshot of one of our participants trying to translate a paragraph, an English paragraph about a Muslim Ethiopian ruler into Amharic. There are several errors in this translation, but I'll highlight two of them here. First, we see that the translation simply copies over the year that the ruler came into power without indicating what calendar system it is in or doing any sort of conversion. And without the context that this came from an English text, the Amharic text would actually be off by about 7 years because the default would be the Ethiopian calendar. A second error in this translation is that the phrase Mahfuz, who wedded his daughter to him, was literally translated to the ruler marrying his own daughter, an error that our participant indicated they fear would have negative connotations, especially considering that the ruler is Muslim. The third set of challenges are social political challenges. We realized that we could not attribute every single obstacle to technology. There were issues, for example, with the lack of resources. Sometimes resources would just not exist. Here's our participant saying, we have nothing, we don't even have suggestions, after trying to edit articles about African leaders in Tigrinya Wikipedia and being told that there are no suggestions for the filter that they've set. Or sometimes the resources would exist, but they would be written by Western scholars and not be available in the local language, and would sometimes be rooted in colonial viewpoints. Our participant says, see, it's the heralds of the world, as she's scrolling down the list of references for one of the Wikipedia articles about an Ethiopian king. There were also issues with paywalls and financial barriers. Here's one of our participants, who is a lecturer at an Ethiopian university, complaining that they do not have access to certain publications and books because their university does not have agreements with the publishing organizations, and those resources would be behind paywalls. We also observed complaints that people did not have resources to buy mobile card data so that they could connect to the internet and edit Wikipedia articles. Here's a timeline of one of our participants in this study that summarizes majority of the challenges that we've observed. They have issues trying to get their Wikipedia, their non-Latin keyboard to work on the Wikipedia interface. They have issues with existing articles existing Wikipedia articles being too short or leading to links that do not exist. They are blocked, or their IP address is blocked by the Wikipedia interface and the cybersecurity measures that the platform takes. And this happens because the participant was connected to a VPN service, which brings us to the social political challenges that we've discussed. The reason that this participant was connected to a VPN service is because certain platforms like YouTube and Telegram were blocked by the were blocked in Ethiopia at the time of doing this session. So now I will bring us to a question that we have thought about a lot while working on this project, and I continue to think about as I am doing my research in general, which is, what if the reason that we do not have data available in these languages is simply because community members do not want their knowledge on there? And we argue in this work that it should be the community members' choice to not have their data on there, and it should not be our design shortcomings that make these decisions for them. We see in this work that even when community members want to put their data on there or try to put their data on there, they have several interacting challenges that prevent them from doing so. So now that we've talked a lot about the challenges that we observe in this space, let's talk a little bit about design opportunities, or what could we do better to make these platforms more inclusive for low resource language speakers. For Wikipedia interface, we see the opportunity to allow users to, for example, select the dialect that they're editing in, so that we avoid those duplicate articles due to differences in spelling across dialects. There's the opportunity to use language ID tools to flag to editors articles or instructions that have mixed languages. And there's also the opportunity to suggest articles that are about the communities but are written in other languages to low resource language Wikipedia editors. So for example, the article on Auramba, which I've talked about around the beginning of this talk, could be recommended to an Amharic, Afan Oromo, or Tigrinya Wikipedia editor to write about it in their local language, which would increase the relevance of the articles available in these languages. In terms of language support tools for machine translation, we see the opportunity to have a more human-centered or human-in-the-loop machine translation system. For example, that would allow people to indicate what calendar system it is in, or do some sort of calendar conversion. We could also rely on back translation to avoid the errors that we observed, for example, with the literal translations. Back translation is a technique whereby, for example, we go from the English text to Amharic and then back to English, allowing us to see the discrepancies in the translation. We could also be more allow users to be more explicit in the inputs to machine translation tools about concepts such as gender, race, ethnicity, religion, etc., so that we avoid some toxic mistranslations. Another design opportunity, which I did not talk about in the findings, but that we see the room for improvement for, is in increasing the input modalities to these type of systems. Currently, these systems are heavily rely on text, and there's the opportunity to use, for example, speech recognition systems, or just to allow people to add and contribute using voice without the need to convert to text. So why do we care in NLP if low resource language contributors have problems with Wikipedia? We've seen the HCI angle, we've seen the design opportunities for the different type of tools that we could build, but Wikipedia is also used as a source for a lot of models in NLP. So the more quantity and quality that we have in these languages, the better data that we have when we are training models for them. And even if we have quantity and quality data, but it lacks relevance, the models that we build upon this data is also gonna lack contextual relevance to the communities who speak these languages. So with that, I will end my presentation and leave you with this figure as a reminder that the challenges that low resource language speakers face when they interact with online systems are not due to just one challenge, but due to several interacting aspects. And I will end with a quote from Ruha Benjamin that technology succeeds by excluding some groups from taking part in its design, intent, implementation, and results. Thank you for listening, and please feel free to contact me at my email displayed below.